Geoenergy is renewable solar energy stored in the bedrock. It will act as a free heat source for buildings and can be collected straight from the ground. Geoenergy is utilised via a heat pump system. The system's central components are a geoenergy heat pump, a hot water tank and a buffer tank. The cold heat collection liquid will travel from the geoenergy heat pump to the heat collection circuit. The heat collection liquid is an environmentally safe mixture of water and alcohol. This heat recovery circuit includes a collection well and 3 energy wells. The energy wells are spread as far apart on the plot as possible. Their depth and number will be determined based on the heat energy needed. In the energy well, the heat stored in the ground and bedrock will transfer to the heat transfer fluid. The heated fluid will then return to the geothermal heat pump via a collection well. An efficient process occurs in the heat pump. The heat recovered by the heat transfer fluid will transfer to the building's heating water and warm household water. The process generates 3 or 4 times the heat energy in comparison to the electricity used. From the geoenergy heat pump, the water used for heating the building travels to the buffer tank. Warm water is constantly cycled to the radiator network from the buffer tank. The warm water travels to the apartments and warms the indoor air through the hot water radiators. When the water cools down, it returns to the geoenergy heat pump. The hot water tank is connected to the cold water supply. The supplied cold water will warm up when it comes into contact with the hot water heated by the geothermal heat pump in the tank's heat exchanger. The warm water is supplied to the residents. The geoenergy heat pump provides the tank with heating water when necessary, and cool water that has transferred its heat returns to the heat pump. The hot water tank size is based on the number of apartments and the demand for warm household water.